So good morning, everyone. So today, as Kerry said, I will look at the unlocking of gigaton CO2 storage capacities by pre-competitive appraisal and the calculation of national theoretical storage capacities in our respective national portfolios, especially within with saline aquifer, can produce some very large numbers, thousands of millions of tonnes or gigatons of CO2. For much of that capacity, it's at a level of understanding that is too low and with too many uncertainties to be taken forward by commercial operators. So this morning, we'll have a look at see how geological survey organisations, such as that, as the British Geological Survey, we can look at what we can do to increase understanding and reduce risk to unlock those national storage capacities. And I would like to use examples of the BGS work in the UK on saline aquifer formations. So firstly, I will consider the level of understanding of saline aquifer formations, well, most of them, their capacities in national storage portfolios, then to consider how to communicate readiness for storage for future CO2 storage operations. But I particularly want to look at where those sites that are at the lower level of understanding. Then I'd like to have a look at the role of geological survey organisations in what we would refer to as pre-competitive appraisal, using UK examples from the southern North Sea and from the central North Sea. And then we can consider how regional scale investigations can support cross-border impacts research, and I'll have an invitation to you there, and then we will consider with a summary at the end. So each country has its own national storage portfolio of prospective storage units. In the UK, underlying the UK adjacent waters and in adjacent other national waters, screening, assessment and planning, and indeed for Norway, operation has been taking place since the 1990s. So in 2020, there are more than 700 prospective offshore sites, and these comprise both depleted fields and saline aquifers. And these are the total of storage units in the Norwegians, Netherlands, and UK national portfolios. So in 2020, only 10 UK sites were sufficiently well known to be able to apply the industry classification that was reviewed by Sylvain to us yesterday. So this was our motivation, to present a tool to communicate storage readiness levels to stakeholders, technical and non-technical, and also and decision makers. So they need to know which stores are better known and why, what more needs to be done, how long will it take, and importantly, how much will it cost for a storage site to become operational. So we presented a framework which is summarized here of 9 storage readiness levels. And we based this on the prior work that we had undertaken on the UK, Netherlands and Norway, which has a sum of more than 700 sites in our regions. So the levels are intended to communicate what has been achieved, but also, and very importantly, what remains to be completed for a site to become operational. The levels are qualitative, not quantitative, as each site will have its own technical and non-technical site-specific characteristics. It's not a classification, there are no hard boundaries between the levels, and so a degree of overlap. Now that flexibility is very useful because it enables us to apply and compare sites within our national portfolio, but also to consider across different permitting jurisdictions. And details of the methodology, technical and planning appraisal activities that might have been completed at each level are included in our published paper, with the link included here. So, storage readiness levels are a high-level communication tool, but they are also consistent with the more detailed industry SRMS project development classification reviewed by Sylvain yesterday. During the project, we took advice from industry to ensure consistency with that classification. And where they occur, the consistent terms are used, where the levels and the SRMS are equivalent. So here then, storage readiness level 6 is equivalent to discovered contingent storage resource. We use the same term for SRL 9, which is on injection. So the important part for me as a person from a geological survey is that the SRL frameworks contains all of the sites in a national portfolio. So this includes the 560 sites that were not sufficiently well known to be able to apply the SRMS in 2020. For geological survey organisations, the progress from storage readiness level to levels 1 to 4 enables us to convey the increase in understanding and the reduction in risk during our initial strategic appraisal research activities. I'm very pleased to say that, as Kerry has mentioned, that the work of the Geological Surveys for Europe project, we have been enabled to apply storage readiness levels to the European CO2 Storage Atlas. So the EU-funded GSEU's Geological Surveys for Europe project has applied storage readiness levels to sites in the CO2 storage layer of the atlas. Here the application is shown, and these are zoomed in into the southern North Sea, and information is shown at trap level at the southern North Sea, and here the storage readiness level is shown by the colour gradations here. So this is very much part of a collaborative project for all the geological surveys in Europe. And this particular activity is led by IGME in Spain, and colleagues are here today in the audience. The work package is led by TNO, who presented the atlas at a launch in Brussels this time last year. So now I'd like to have a look at pre-competitive appraisal in the UK. So the UK ambition is for 20 to 30 million tonnes per year by 2030, at least 50 million tonnes per year by 2035, and up to 170 million tonnes per year in 2050. But the good news is that we have a significant theoretical UK storage capacity of 78 gigatons, of which 60 gigatons is within saline aquifers. However, we have already said a lot of that is very much at the theoretical level. So BGS studies commenced with regional appraisal and capacity calculations in the Bunter Sandstone in the southern North Sea. I got a pointer. So, oh, it doesn't matter. So I can't work the pointer, does it? Doesn't matter, Kerry, it doesn't matter. So there in the southern North Sea, we can see the interest from the Bunter Sandstone, and our regional appraisal and capacity in calculations informed subsequent applications for commercial projects. Our more recent research has assessed connectivity and pressure interaction, and this is to inform the planned projects. So later in this session, my colleague Lucy Abel, will be presenting the BGS work on the Bunter Sandstone, its history, and also recent research to assess connectivity and pressure interaction for these many proposed projects. So of interest to me then is the colours that you can see in dark blue. So in the histogram at the top, you can see the central North Sea has 60% of the UK storage capacity, yet as you can see from the map, in dark blue, the licensed and interested areas are underrepresented by licensing activity. So I'd like to look more closely at the central North Sea, and I'd like to zoom in here and look at this, hopefully you can see it, yellow shaded area. In this yellow shaded area, it is underlain by sandstones of Paleogene age containing brine, so saline aquifers. So the capacities of these Paleogene age sandstone in the central North Sea, approximately 5 gigatons, and they extend much further north, and it's probably 6 gigatons in the northern North Sea. Of interest then, for example, the May sandstone has the largest storage capacity of any individual unit within the national portfolio at 3.7 gigatons. So the sum of these two regions in these Paleogene sandstones, it significantly exceeds theoretical capacity of the Bunter Sandstone, which has had so much current commercial interest. The very interesting nature of these sandstones is that the capacity is distributed within multiple geological formations that are widely distributed. And so what I'd like to do is give you an indication of their characteristics, their natures, and we'll have a look at a cross-section from northwest to southeast in this next slide. And this is an illustrative stratigraphic cross-section from northwest to southeast, from left to right. And we can see the yellow sandstone-dominated formations, and we can see the grey non-sandstone formations. From the image there, you can see that the yellow formations are laterally extensive, and they may be laterally connected. Vertically, they may directly overlie each other, or may be separated by thin non-sandstone intervals. So for geological survey perspective, there are some key issues identified for our investigation. Definition of storage complexes in this stacked sequence. How to distinguish hydraulic units. What is the containment risk where the intervals between them are not well known? What about then the consequential overall storage capacity risk? And also to consider the cross-border implications. So our initial project activities in this frontier area has been by the regional collation and interpretation of well and seismic data. So our interpretation commenced in 2024, and our initial focus has been on the interval from the Echo-Fisk to the boulder formations, and it includes the May, and as we previously described, and also the 40s sandstones. We have a poster outside looking at this in more detail next to the area where coffee is served. So please do go and have a look. So our images here show the results of the interpretation of our initial mapping. So on the left-hand side, we can see the structure contour map to the top boulder formation at the top. We can see isopack thicknesses there of the interval of our interest, and an image here shows the ties between the seismic and well data. We have 192 wells included in our investigation in this area. So the right-hand map shows the East May license area, and that's that sort of grey-hatched area. And it is where we started doing our area of interpretation, which is the dark green. But the map also shows us something very interesting, and the proximity of the East May license area, which is to be the second store for the Acorn project, and its proximity to the international border. So prior BGS research has commenced in the southern North Sea, which in this map of potential CO2 storage capacity ranking, this is prepared by the UK competent authority. So that area down in the southern North Sea, adjacent to the international border, we have found from prior research that there is a potential for cross-border brine displacement and pressure effects. So the area in the central North Sea, which are now investigating, is similar potential for storage appraisal and similar proximity to the international border. And this is my invitation now. We are open to exploring the regional cross-border effects and the implications to stakeholders with partners and neighbouring countries. So what will be our starting points for these works? Well, we will have better definition of the cross-border hydraulic units, to be able to integrate our respective structural and stratigraphic understanding in our adjacent jurisdictions. This to enable us to model the magnitude and extent of the pressure response, and therefore to also particularly to have a look at the footprint of the pressure response where there are the presence of known legacy wells. Also to consider the potential pressure interference of in adjacent jurisdictions, particularly to consider fluid flow and the potential for brine displacement. So our objectives for this work to unlock the potential storage in the saline aquifers in this area is to increase understanding and decrease risk. And this is for our stakeholders, both the regulators and operators. And we hope that this will be an example of a collaboration and examination that we could apply to international borders elsewhere in the North Sea and indeed elsewhere. So I must acknowledge my UK, Netherlands and Norwegian storage readiness level co-authors, the prior and current research projects, including the GSEU, and particularly a big heartfelt thank you to our funders who have supported the research presented today. So then to summarise, the challenge for organisations such as my own for geological surveys is to increase understanding and unlock the saline aquifer capacities in our respective national portfolios. Readiness levels convey what has been achieved and what remains to be completed for a site to become operational. The readiness levels framework includes all of the sites in a national portfolio, and we are able to use, using storage readiness levels 1 to 4, the increased understanding and the risks reduced by pre-competitive research appraisal, such as organisations as my own. In the southern North Sea, our assessments, our regional assessments of capacity and containment informed subsequent commercial projects. More recent work on connectivity and pressure interaction informs the currently planned projects. BGS studies now consider a frontier area in the UK of saline aquifer storage capacity, which is underrepresented by commercial activity. Our regional mapping of sandstones in this frontier area highlights the need to better understand formation connectivity, that to inform storage complex definition, distinction of hydraulic units, containment and a capacity risk, and cross-border brine displacement and pressure effects should it occur. So BGS will consider cross-border implications, and again, we are open and welcome to explore cross-border effects with partners and neighbouring countries, such as those in the audience today. So thank you for your attention.